Okay, class, I want to welcome you to the online section of Software Applications for Engineers for Spring 2015. Our first assignment that we got this morning says that we have a water inlet sensor measuring the inlet to a chemical reaction tank, and we know that the water's coming in and varies from 7,000 cubic meters per minute down to a minimum of 5,000 cubic meters per minute in a sinusoidal fashion with an oscillation period of 15 minutes or 4 times per hour. We're engineering interns, and what we want to do is we want to plot the inlet to the tank, and we're going to first find the frequency F and the circular frequency omega. So what I'd like to do is set these problems up on paper. If we don't, guys, you're just going to get messed up if you try going right into Excel, or at least I did as a student. So let's write down what we know. We've got the frequency is 4 cycles per hour. And we're going to have to change the units, and this is very basic for most of you, but I want you to write the units out when you're solving a problem. So we got 1 hour is 3,600 seconds. So I'll use my calculator and take 4, divide that by 3,600. And I'm getting a frequency of 1.11 repeating times 10 to the negative third cycles per second, and that is hertz. So we've got a frequency of 1.11 repeating times 10 to the negative third hertz. And that is what the answer is for part A, and we want to put that in cell E2 on our spreadsheet that we'll get to after we set this up. Now we know that the mass flow rate, we're told, is some average mass flow rate, which is just going to be the average of the max and min amplitude plus the amplitude times sine times omega t. And what we need to do is calculate the circular frequency omega. So that's going to be the frequency f times 2 pi, and we'll see in a minute why the 2 pi comes into this. So we got the frequency of 1.11 times 10 to the negative third cycles per second. And what we want to do is get this in to radians per second. So that's where the 2 pi, so there are 2 pi radians in one cycle. Those will cancel, and I end up with an omega. I'm getting 6.98 times 10 to the negative third radians per second. You guys check that out and make sure you agree. So if that's true, that is going to be part B, and it says that we've got to put that into cell E5 of our worksheet and report it. So now we know that our mass flow rate that we're going to calculate is going to be the average, which is going to be m dot max, which was 7,000, plus m dot min, which was 5,000, divided by 2, which gives an average or a DC offset of 6,000 cubic meters per minute for the water flow rate into the tank. And I can just write m dot now by knowing that this is going to be 6,000 plus the amplitude we know is 1,000 from 6,000 to 7,000 times the sine of omega t. Now what we have to be careful of, guys, is that t is in minutes, so we really need to make sure that we convert that to seconds in our formula on our spreadsheet. If we don't, we'll get in trouble. So guys, that's how we set this up. We're going to take a break now and switch over to the software and see how we can implement these computations into Excel. Thanks.